We are doing question number 1 of May 2022 paper 4-2. This is a very straightforward and a simple question related to stacks. So let's start. We are using the stack data structure. It can store up to 10 integer elements, so the array size will be 10. And then they're saying write code to declare the array and the pointer as global data structures, initialize the pointer to 0. Very simple. So we have stack data and we're initializing it to all 0. So the 10 values. So maybe we can write 0 for I in range 10 like this. And then we are setting, in fact, let's set it to -1. Unless they've specified it, space tag is initialized to 0. Okay, it's set to 0. Okay, then the next part is we have the stack pointer, which is also set to 0. This is done. In part B, they're saying that you have to write the procedure to output all the 10 values from the stack. And this should be done one line at a time. So define, let's call it print stack. And for print stack, we are going to globally access the values and the value stack pointer as well. Okay, so we can just print stack value pointer, top pointer at, and we can put the value stack pointer. And then we have to print all the 10 values. So for maybe item in stack data, we just print the item, so it will automatically print on a separate line. Or you can also use the for I in range method, but in this case it's simpler. The function push takes an integer parameter and returns false if the stack is full. If the stack is not full, it puts the parameter value on the stack. Okay, so the stack pointer is already initialized to the next available space, which is set to 0, which means first we'll place the value and then we'll increment the stack pointer. So push, let's say we have a new item here, and then we are going to add it into the stack. First of all, we have to check if the stack is full or not. So the same logic, we will globally access the variables and global stack pointer, and then we're going to check if the stack pointer is equal to 10. So what will be the logic behind it? So if it starts from 0, we are going to store at 0, and then we're going to do +1. Eventually, when we'll be at the 9th index, we'll store the value there. So from 0 to 9, it would have stored 10 values, right? So when we'll do +1 and it gets pointed to 10, that means that the stack is full. And that is what we're doing here. So if the stack is full, so we have to return false. Okay, if the stack is not full, then we are simply supposed to push the value into the stack. So what we are going to do is at the stack pointer's index, we are going to put the item into our stack data array, and then we'll do stack pointer plus equal to 1, and we're going to return true like this, right? Then they're saying edit the main program to test the push function, and the main program will be written. Okay, let's hide these functions so we have enough space. All right. Allow the user to enter 11 numbers and attempt to add these to the stack. Output an appropriate message when the number is added. Output an appropriate message when it's not added, etc. Okay, very simple. You just have to write print statements here. Let's try this. So for maybe I in range, they're saying 11 times. For 11 times, we have to get the item from the user. int input enter stack item, and then we're going to attempt to push it onto the stack, and we'll get a response back. Response is equal to push the item. So if the response is equal to true, or we can just leave it like this. If the response is true, then we'll say print item, or let's use a forward string. This value was pushed successfully. Or you can print anything else. Okay, else if the value of response is false, then we'll say was not pushed, or we'll say can't be added on stack. when the number is not added, when the number is added, and then output the contents of the stack after attempting to add all the 11 numbers. And then after this is done, we'll just simply call the print stack method that we have already written, and then they're asking us to test it. So the items are, so this is the output. We added values all the way till 20, so 21 was not added because the stack became full, and then the top pointer was pointing at 10, and then these are all the values, first come last, sorry, it should be first and last of. So this is what we get, 11, 12, 13 starting from 20. Looks good so far. Then they're saying now you have to write the pop function. So we'll go here, define pop, and pop doesn't need any parameters. It will return -1 if the stack is empty. So when the stack would be empty, what would be the case? So if we keep on decrementing the values or removing the values from the stack pointer will go back to being at 0 because 0 is the starting position of it in this case. So if the stack pointer is already pointing to 0, which is the default as given in the question, we'll simply return -1. Okay, if that is not the case, then we are going to pop the element, we're going to store it, we're going to return it. Okay, if that is not the case, then let's call it deleted. Deleted is equal to whatever the value we have stored at the top of the stack or the stack pointer index, we'll store that. We'll decrement the stack pointer by 1, and then we'll simply return the deleted value, right? So yeah, I think that's fine. We don't need to test it again. It will just remove the value. Well, it's not technically deleting the value, it's just updating the pointer. So next time when we add a new value, it will override the previous one, but we are not literally deleting the value. Question is saying that you have to remove 2 values from the stack. So you have to use the pop function now twice, remove 2 elements from the stack using pop. So I'll use pop and pop twice. Output the contents of the updated stack. So print stack, and then we're going to output it again. So let's input the values. We have 11, 12, 13, 14, 15, 16, 17, 19, 20, and 21. Okay, so we got an error here. So let's figure this out. Okay, there's one mistake here. The question says that the stack top is, so the top is pointing or storing index of next available space, right? So the top will always be one step ahead of the current last saved value. That is why when I try to access the last saved value, that will be going out of the index. So I have to subtract 1 from it. In fact, if I do it beforehand like this, and then I return the value at this index, then it would work, right? So it lands the pointer at the current last element in the array. Let's try again. Here we go. It says 11, 12, 13, 14, 15, 16. So 21 was not added. And then we remove the values. And then it is, okay, so it's still showing us the same values, but the top pointer was initially at 10. Now it has shifted 2 places down. If you want to test it further, what you can do is that whatever value that you're deleting, you can put an X over there. But that is not part of the question. That will be purely for testing purposes. And with this, we'll take a screenshot of this and the question is done.